Hello, my name is Steve Bowler, and in this video we're going to be taking a look at Enhanced Interior Gateway Routing Protocol, otherwise known as EIGRP. Specifically within EIGRP, we're going to take a look at the concept of split horizon and when you might see it when you are using EIGRP as your routing protocol. And we're also going to be taking a look at a way to get around the split horizon rule. Specifically, in this case, we're going to be taking a look at the point to multi-point scenario where you're using a where you're using a physical interface and you have a hub and spoke design in your network. In this case, we're going to be using R1 as our hub router, and R2 and R3 are going to be our spoke routers. And a lot of people know about split horizon through the routing, through the routing protocol RIP, but a lot of people do not or have not seen split horizon take effect in an EIGRP environment. And that's why I'm making this video, to kind of bring awareness to the split horizon scenario that you might see within EIGRP. A lot of people know about the EIGRP K values, how it uses the 5 metrics to find its best path through the network. And a lot of people, though, are not aware of one of EIGRP's rules, which is split horizon. Because EIGRP has a lot of different rules to it. It's more of a hybrid routing protocol. It uses a lot of different metrics, and also it uses, as we'll see here, it does use hop count as one of its metrics. Probably very rarely seen, but we will take a look at that. I'll show you that within the EIGRP command set too. But mainly in this lab, we're going to be taking a look at split horizon, when you might see it, and what we can do to proactively be aware of this situation, and how to avoid routes learned from one spoke router to be seen at the other spoke router. So in this case, split horizon, if you're not aware of what it is, basically the rule of split horizon says that updates received on an interface will not be sent back out the same interface. In this case, router 3 sends an update to router 1 over its serial 00 interface. Router 1 in turn will not send this update back out its serial 00 interface out to router 2. So what we're going to see in this scenario is that router 3's loopback 0 interface, once we advertise it in the EIGRP, what we're going to see is router 2 not receive that loopback 0 interface, and also the same thing with router 2. And this is all because of the split horizon rule that's going to be in effect on router 1's serial 00 interface. So let's go ahead and get into the routers. Again, we're just going to set up a very basic point-to-multipoint configuration here within EIGRP frame relay. We're going to have router 2 and router 3 is the hubs, and router 2 and router 3 are going to be the spoke routers, the end routers, and router 1 is going to be the hub that connects everything together. Again, I've already set up the frame relay network. Router 1's pretty much using 102 to connect to Delcy 102 to connect to router 2, and Delcy 103 to connect to router 3. And router 2 is using Delcy 201 to connect to router 1, and router 3 is also using 301 to connect to router 1. So let's go into router 1. We'll go ahead and set up its serial 00 interface here. First thing we want to do is give it an IP address. And again, let me show you the diagram. We're going to be using the 192.168.1.0/24 network for all these routers. So router 2 serial 00 interface, router 3 serial 00 interface, and of course router 1 serial 00 interface. They're all going to be in the one network. And we have two loopbacks here. One on router 3 is going to be the all3 network, and one on router 2 is going to be the all2 network. So we're going to go onto router 1 here. We'll do encapsulation frame relay. Then we're going to go ahead and do our commands here. Frame relay map IP 192.168.1.2, and then we're going to be mapping that over Delcy 102, and then we're also going to be doing router 3s over Delcy 103. Now what we're also going to do here is we're going to do a no frame relay inverse ARP, so that we cannot dynamically learn the layer 3 to 2 mappings from Delcy's to IPs. We're going to be putting those in statically here, our layer 3 to 2 mappings, as you can see with our static frame relay map commands. And we'll go ahead, the last thing we'll do here, first we'll do a no shut. And what you might have already noticed is we're not using the broadcast statement at the end of the static mappings, and I'm going to show you what happens when we do not do that. On router 2, let's go ahead, actually on router 1, let's go ahead and set up the frame relay EIGRP while we're there. We're going to be running EIGRP AS, our autonomous system number 1. Do a no auto summary to disable automatic summarization at classical network boundaries. And we'll go ahead and run EIGRP for network 192.168.1.1. Let's use a host mask here. This is only going to allow EIGRP updates to be sent out an interface that has this specific IP address only on it. And that should be it for now for router 1. So let's go to router 2 and get it configured. Interface serial 00. Give it the IP address first. 192.168.1.2. Go ahead and give it the frame relay encapsulation. We'll do a frame relay map IP 192.168.1.1. We'll map to router 1 over Delcy 201. Also, we're going to map to our router 3, so we're going to do a frame relay map IP 192.168.1.3, and again that's going to be over Delcy 201. Again, we're going to do no frame relay inverse ARP, and we'll go ahead and do a no shut here. Now I don't know if I did a no shut. Yeah, I did on router 1. So okay, router 1 is good, router 2 is good. Let's go to router 3 now. Get it set up, and then we'll check full, reachability between the interfaces. Actually, I forgot to enable EIGRP. Let's go back to router 2 real fast. We'll do a router EIGRP1. We'll do a no auto summary. And then we'll do a network command here of 192.168.1.2 host mask. And then we'll do a network command just putting in the whole 2 network. So router 2 is all set with EIGRP. Router 1 is set as well. Let's go to router 3 here, and we will do give it an IP address on its serial 00 interface of 192.168.1.3. Give it a /24 subnet mask. We'll go ahead and put on there a frame relay encapsulation, and we'll do a no frame relay inverse ARP. And we'll go ahead and do our mapping statements, our static frame relay mapping statements. So frame relay map IP 192.168.1.1. Again, that's going to be over Delcy 301. And we'll do a frame relay map IP 192.168.1.2, which is router 2. Again, it's going to be using Delcy 301 to connect to router 2. Last but not least, we'll go ahead and no-shut the interface. Now we'll go ahead and enable EIGRP Autonomous System 1. We'll go ahead and give it the network command 192.168.1.3 with the host mask, and then we'll also give it a network 3.0.0.0 for its 3 network. Also, we need to create our loopback. Looks like I have some debugging commands on here. We'll go ahead and take those off. Oh yeah, so it says here that it's a summary. Let's go ahead and do a no auto summary here on router 3 before we forget. Also, what we want to do is set up the loopback 0 interfaces on router 3 and 2. So on router 3, we'll give it the IP address of 3.3.3.3 and a /24 subnet mask. Let's go to router 2 here before I forget. We got to set up its loopback 0 interface. So we'll do IP address of 2.2.2.2 with a /24 subnet mask. Okay, so now that everything is configured, if we go to router 1, we'll just do a show IP route. Shouldn't see anything right now, and I'll tell you why here in a second. On router 1, again, let's go ahead and just ping router 2 and verify we have 192.168.1.2. We have reachability to router 2 and we have reachability to router 3. So let's go, the last thing we need to check here is just to make sure the spokes have reachability to each other. On router 2, we'll just do a ping 192.168.1.3, and we have reachability now. Again, if we look at our show frame relay map command, you can see our mappings here. We're mapping to router 3 over Delcy 201, so we have our layer 3 to 2 mapping, and we're also mapped to router 1 over Delcy 201. So as you can see here, we have full reachability. We don't really have to test any farther at this point. On router 3, we don't have to go on there and do anything because we know that it responded to router 2, so we know it has reachability back to router 2. Thing I wanted to show you, I was talking about earlier how EIGRP uses hop count. If we just do a show IP protocol, we look and we see EIGRP autonomous system number 1, and as you can see here, we do have EIGRP maximum hop count 100. So EIGRP does indeed use hop count as one of its metrics. So if hop count gets over 100, then it's going to be unreachable. Of course, you can change this. You can, tweak this metric along with all of its K values. But I just wanted to show you that a lot of people, aren't aware of, how it uses hop count. It also uses split horizon. That's why I'm doing this video, to show you where you might get stuck in seeing this, what kind of situation you might see this in, and how you can get around it. So again, EIGRP is a hybrid routing protocol. It uses a lot of metrics and a lot of rules from several different routing protocols like RIP, OSPF, and others. So okay, back to our diagram here. What we can see now, and what you might be thinking is, okay, well, why don't we have any EIGRP neighbors? If I do a show IP protocol here, or a show IP EIGRP neighbor on router 1, you see that we are learning of no neighbors. We have no neighbors on router 1. If I do a show run, pipe to begin EIGRP, let's take a look at our EIGRP configuration on all of our routers. Show run, pipe to begin EIGRP. And as you can see here, all of our routers here have our network statement for our directly connected physical interface here over the point-to-multipoint connection over frame relay. So why are we not seeing our neighbors? And some of you already might have figured it out. The reason we're not seeing our neighbors is because we did not specify the broadcast command at the end of our static frame relay mapping configuration. So in the point-to-multipoint configuration, where you're using the physical interface and not a sub interface, what we have to remember is to put in the broadcast command. So we'll go to router 1 and I'll show you exactly what's going to happen here when I do this. Actually, let's do a couple debugs real fast. We'll do a debug IP packets. Let's see what's going on here. Debug IP EIGRP. And on router 2, we'll do the same thing. Debug IP packet. Debug IP EIGRP here. Doesn't look like router 1's talking much at this point. Let's just do a show IP interface brief just to make sure that it's okay. Just make sure we have, there we go. Encapsulation failed. That's what we wanted to see here, is that the encapsulation is failing because these commands do not have the broadcast. Our static frame relay mapping commands do not have the broadcast statement at the end of them. So these messages are trying to get sent over, So again here, we're seeing encapsulation failed when we're trying to send, these messages out. The EIGRP, as you can see here, 224.0010 is the EIGRP multicast address here that it sends out, and then you can see here it's sending out its serial interface, and we're getting encapsulation failed. Again here, the broadcast statement is going to tell the router to forward the broadcasts over, or the multicast in this case, over our frame relay link, our DELC here. So that's why we're getting an encapsulation failed, because we haven't specified the broadcast command. So we're just basically doing this to move the packets out of the router over to router 2 and router 3. So we'll go on to router 1. We'll go ahead here and do a interface serial 00. We'll go back here and do a map. We'll go ahead and map to router 2. I'll show you this in router 2's case here. Once I put in the broadcast statement, before we were getting encapsulation failed sending out these messages. And now, as you can see on router 2 at least, we're seeing an adjacency has been formed. Let's go ahead and stop all the stuff on router 2 real fast. I can show you this. And what we're going to see here now is a one-way neighbor relationship. So what we're getting on router 2 is we're getting, the dual is run, and we do have a neighbor adjacency with router 1. So if I do a show IP EIGRP neighbor on router 2, we can see that we are seeing router 1 as a neighbor. However, if we go to router 1, if I do a show IP EIGRP neighbor, we have no neighbors still. And that's because we have to configure the broadcast command bidirectional here. So router 2 is also going to have to send this broadcast, set up this broadcast statement on its side. If not, then we're not going to have a bidirectional neighbor relationship. Again, the broadcast command is used to forward, these broadcasts over the frame relay connection here. That's why we're getting an encapsulation failed. because it's not forwarding it out to Delcy. And in that case, we're having big problems here. And also you're going to have big problems if you don't set up the broadcast. In this scenario, if you don't set the broadcast statement up bidirectional, then you're going to have one-way neighbor relationship problems. So let's go into router 2. We'll do a frame relay. Let's just take a look here. Let's go. We'll do the broadcast statement here on router 2. And what we should see here on router 1, and we do see it here, is our neighbor, a new adjacency. Right here with router 2, as you can see, 1.2. And you can see, router 1 is updating its routing table with some of the metrics to reach router 2, and also I believe it's also installing a route here to the 2 network, which is off of router 2. So now if I go into router 1 and do a show IP EIGRP neighbor, what we see now is we are actually seeing router 2 as a neighbor on router 1, and also if I go to router 2, we're seeing the neighbor relationship as well. So this is the correct way to have EIGRP run in this scenario, where we're doing a point to multi-point using the physical interface over in an EIGRP network over frame relay. So it's very important to include your broadcasts there at the end of your static frame relay map commands. If not, you're going to run into problems. And we just analyzed those problems and troubleshot it, and we were able to see exactly what was going on. So on router 1 here, if I do, as you might be thinking here, we're going to have to do the same thing to router 3, our frame relay static command to router 3. So we'll do a frame relay map IP 192.168.1.3 over 103 and broadcast. And now what we'll see, what you might see here, we won't run any debugs on router 3, but as you can see here, we're seeing the neighbor relationship form on router 3. And now we're seeing this information being routed via the rib, whereas before we were getting encapsulation failed messages. So everything looks like it's running normal now. If we go to router 3, if I do a show IP EIGRP neighbor, what we see, we're peering with router 1, which is good. However, as you might have figured out, if I do a show IP EIGRP neighbor on router 1, I am still only seeing router 2 as a neighbor. And that's because, again, the broadcast statement at the end of the frame relay map command has to be bidirectional. So we enabled it on router 1 here. Now we have to go to router 3 and enable broadcasts back to router 1 in this case. So again, the keyword broadcast in this case is going to allow us to forward broadcast over our frame relay link over the, when we have our connection here with the frame relay map IP. Again, all we need to do in this case is set up the keyword broadcast to our neighbor router 1. So we'll go ahead and do that command, and now what we should see on router 1 is an EIGRP neighbor relationship form here. So we'll give it a second on router 1, and if I do a show IP EIGRP neighbor, we don't see router 3 yet, and we should see it here very soon. Let's just take off all, I'm going to take off all of our debugs commands and give it 1 second. And now you can see that we have our neighbor relationship with router. So now we can see that our neighbor relationship has formed with router 3. If I do a show IP EIGRP neighbor on router 1, you can see that I'm peering both with router 3 and router 2. So everything looks normal at this point. If I go to router 3 now, if I do a show IP EIGRP neighbor, you can see that I'm peering with router 1. So everything looks normal at this point. Also, if I do a show IP protocol, another way you can see this is by you can see routing information sources here. We're seeing router 1 as an information source, and the distance is 90. So we can tell that this is a EIGRP neighbor relationship over, to router 1. So now we want to check for full IP reachability. Now we're going to take a look at the split horizon problem that we're going to run into in this situation. If I do a show IP route on router 1, as you can see, router 1 has both of the EIGRP learned routes installed into its routing table. I can go ahead and try to ping them. Again, I can ping router 2's loopback 0 interface, and now I can ping router 3's as well. So from router 1's perspective, the network looks fine. Again, the router 1 is the hub. Let's go to one of the spokes here. Let's go to router 3. If I do a show IP route on router 3, as you can see, router 3 only sees directly connected interfaces, and it does not see router 2's loopback 0 interface that it's advertising in EIGRP. Let's go to router 2, take a look at its routing table. Again, all it sees is the directly connected interfaces, and it does not see the EIGRP learned route, which should be the 3 network from router 3. And the reason for this, again, is the split horizon issue that we're running into. Router 3 is sending its EIGRP updates to router 1 over router 1 serial 00 interface, and by default, router 1 is not going to send these updates back out the same interface in which it learned it. Again, that's the rule of split horizon. So router 3 is seeing the update, and that is why router 2 is not seeing those updates. It's because router 1 is blocking those updates from going back out the interface in which it learned in which it learned them. Again, that's the rule of split horizon. Same thing for router 2. Router 2 is sending its EIGRP updates to router 1 to router 1 here, and router 1 over router 1 serial 00 interface. However, when router 1 sees that those updates are learned from its serial 00 interface from router 2, it is not going to send those updates back out the same interface in which they came in on and out to router 3. Again, this is EIGRP split horizon on a point to multipoint connection over the physical interfaces. So let's go to router 1, and we'll go ahead and just take a look at what we can do on router 1 to fix this problem. Again, because router 1's view of the network looks fine. However, router 2 and 3 do not have full IP reachability in this scenario. Again, you might see this scenario, in an exam or something. They might try to trip you up. So it's very important that you're aware of this scenario. And the way we combat this issue is we'll just go under the physical interface here on router 1, and we'll do a no IP split horizon, and we'll follow it up with a question mark here. As you can see, we're going to use EIGRP, and then we're going to use autonomous system number 1. Let's go to router 2. When this occurs, we'll just do a debug IP EIGRP on router 2, and we're just going to take a look and see what happens once I enable this command. So if I go ahead and hit enter on router 1, as you can see, router 2 is immediately bombarded with some updates. As you can see, it's processing incoming update packets from router 1. And as we can see now that it is what we need to be aware of too is that EIGRP is going to reset its connection to its peers. So once I do the no IP split horizon EIGRP1 statement on router 1, it's going to do a graceful restart to router 2 to its peers, which are router 2 and router 3. So it's going to reset the connection and then send these packets back out, these update packets, to its neighbors. And as you can see now, EIGRP is now installing, as you can see with this command, or I'm sorry, with this output here, route installed for 3.3.3.3. I'm sorry, 3.3.3.0, which is router 3's loopback0 interface. So as you can see on router 2, we are getting the route installed for router 3's loopback0 interface. If I do a show IP route now on router 2, now we can see that we have reachability to router 3's loopback0 interface. Let's go ahead and try to ping that. Don't know what I was thinking there. And as you can see, we do have reachability now to router 3's loopback0 network. So if I go to router 3, let's just verify that we're seeing the same thing here. As you can see, we see the statement here for the graceful restart, because again, once we issue that no IP split horizon EIGRP1 command on router 1's serial 00 interface, it's going to reset the connection to the peers. If I look at the routing table on router 3, now we see the EIGRP learned route now that is router 2's loopback0 network. Let's go ahead and try to ping it and verify that we have full reachability. And we do. Okay, a few things just to recap here. EIGRP, for EIGRP, split horizon is enabled by default. What we want to do is let's take a look at our diagram here. On our hub router and a hub and spoke, EIGRP implementation, what we want to do is turn off split horizon for whichever EIGRP autonomous system we're running. In this case, we turned it off for EIGRP AS1. And what this allowed us to do here, router 3 was sending updates to router 1. Router 1 was processing those updates and updating its local routing table. But however, with split horizon enabled on the serial 00 interface, it was not sending these updates back out the same interface in which it learned these updates and out to router 2. So in order for router 2 to see router 3's loopback0 interface and vice versa, what we had to do is disable split horizon on router 1's serial 00 interface. And once we did that, router 3 was able to send updates to router 1 over router 1's serial 00 interface, and router 1 was able to, process those updates and send them back out the same interface in which it received them, which is serial 00. So it sent those updates back out to router 2. And vice versa. Router 2 was now able to send updates to router 1 via the serial 00 interface, and router 1 was able to process those updates locally and send those updates out to router 3. The other thing that we learned about is the broadcast statement. In this scenario here, we had to have it on. Without the broadcast statement, if I do a show run interface serial 00 on router 1, I'll show you what I'm talking about here. The broadcast statement at the end of our static frame relay mapping commands. Without this statement on here, our neighbor adjacencies were not able to come up, and that's because the broadcasts weren't being sent out, the frame relay link. So we had to enable the broadcast statement on both sides of the connection here. Otherwise, we did see the scenario in which we were seeing unidirectional neighbor relationships. So in order to get the full bidirectional EIGRP neighbor relationship, we had to enable the broadcast statement at the end of our frame relay static mapping on both the hub router and, as I'll show you here as an example, on router 2. If we do a show run interface serial 00 on router 2 as well, we use the broadcast statement back to router 1, which was the hub. So very important. Without those broadcast statements, your EIGRP neighbor relationship was not going to come up in this point to multi-point EIGRP over frame relay network type, which is peering, where we're using serial interfaces. I'm sorry, the physical interface. Again, the split horizon command on router 1 here is no IP split horizon, and then EIGRP, and then the AS number, which is AS1, is the AS number we were running EIGRP in this network topology. Once we enabled that command, or once we put that command in, we had full IP reachability now. All routing tables are current and present. As we can see, we have the EIGRP learn routes on router 1. We have router 3's network on router 2. And on router 3, we have router 2's EIGRP network. So again, just be aware of this scenario. You might see it within EIGRP. They might try to trick you up on a test or something. Just be aware, if you're not learning the spoke routes, if you go into router 3 and you're not seeing router 2's spoke being sent, it's a network EIGRP network being sent to you. Just be aware, and you verified all the settings are correct on your router, your peering, your adjacencies are up. You can ping through to router 3. Everything is good, but you're not seeing the networks being sent out to the spokes. Just verify again that you want to go into your hub router and turn off split horizon. Hope you guys have enjoyed this video, and I hope you'll be with me with the next one. Thanks.